Intel reached out to sponsor a video where we water cool one of their wicked fast Raptor Lake HX gaming laptops, and Alex had lots of wild ideas.
And you chose the worst one.
Hey, I mean, for one thing, this was your idea in the first place, and for another, unlike what we usually do, this is something you may actually want to replicate at home. If all goes according to plan, this $30 laptop water cooling kit from AliExpress should take about an hour to install, should boost performance when it's hooked up to water, and it should allow our machine to operate normally when it's not filled with water. Though, not gonna lie, I kind of expected more.
What are you talking about? We've got so many things in here. We have pump, we have plastic tube, we have these cool little copper tubes, and even a free gift.
Wow, we're gonna be voiding our warranty, aren't we?
Oh yeah, every time.
And we're gonna tell you about our sponsor. Wait, our sponsor's Intel.
Yeah.
Why did we put a sponsor segue in here?
Hi, Intel.
As much as we meme on AliExpress for all the silly things that you can get there, it can be a legitimate way to get electronics and other goods for relatively cheap, and we found it to be much more reliable than competitors like Wish and Temu. So let's have a look at what we got this time. This is a 5.5 to 12 volt submersible pump based on the suction cups, probably intended for aquarium use at some point, but should serve our purposes very nicely. This is some inexpensive flexible tubing, and this is the star of the show, what appears to be a couple of flattened heat pipes or other copper tubes that have had the ends hacked off and then replaced with what appears to be threaded inserts for woodworking.
Wait, what?
Look.
Oh my God, they are.
Well, they're plastic inserts.
Overall, the kit's a little on the improvised side. There's no instructions, just a bunch of zip ties, but our plan is pretty simple for a change. We just need to somehow attach this flat copper tube to the existing heat pipes in the underside of this laptop, get the threaded inserts to the outside somehow, then run some water through it, cooling the aforementioned heat pipes. This is not going to work as well as directly water cooling the CPU and the GPU, but believe it or not, we've seen commercial solutions not dissimilar to this from companies like XPG and Electronics, and they work surprisingly well. Now, let's take a closer look at our test subject. It's the ASUS ROG Strix SCAR, featuring an RTX 4090 mobile with 16 gigs of GDDR6X memory and a 175 watt TGP. This is effectively as fast as a laptop gets in the GPU department, and honestly, we're not expecting our water cooling to help it go any faster, because NVIDIA limits how much power laptop makers are allowed to give to the GPU. Not so for the CPU. At the heart of this machine is Intel's Core i9-13980HX. I'm talking 24 cores, 8 performance, 16 efficiency, a maximum turbo of 5.6 gigahertz. This is effectively the same as a desktop Core i9-13900K, but with a tweaked version of the Intel 7 process that's tuned for lower power, which makes sense given it has a 65 watt TDP in this chassis and a maximum power of 157 watts. And it's unlocked, meaning we should have some room to overclock. It's also got a 240 Hz 1000 nit mini LED display that runs at 1600p. It's got RGB all over the place. Thing looks awesome. Enough about that though. Let's get this cooler ripped off. Is this a chassis intrusion thing? Dang it, ASUS. I think it's at least easy to fool. No, really? Oh, that blows. Wow, they've given a lot of thought to airflow management in here. Look at all these little foamy bits. They are making sure that when these fans draw in air, they're pulling fresh air from the outside, and only fresh air. Actually, not quite only fresh air. It'll pull a little bit from over here, drawing it across the RAM, the SSD, other more different SSD, and then this guy right here is really cool. That's drawing fresh air in and then blowing it across the VRMs here. What a cool design. And we're gonna rip it all out.
Maybe before we do that, we plan out the heat pipes and bend them.
Now tell me what you're thinking. In one side, out the other, we go kind of swamp like that, or are you gonna try and just run this across here and reach the outside right next to each other?
I was thinking that we would do one for CPU, one for GPU, have them coming out each side.
Seriously?
Yeah. About little Y splitters so we can run them in parallel.
I mean, it's not the dumbest thing we've ever done.
Oh, far from it.
How flexible are these things?
Well, they're
Quite flexible.
They're quite flexible until you flex them, they work harden, and then they become brittle.
Got it.
I was also imagining this kind of sticking out like that much.
What?
Well, like we can try and
Oh,
get it.
Alex.
But also like, realistically, we have to just gouge this whole thing. So the exact Z placement doesn't really matter.
Okay, I got this. I got this.
It's actually really easy to bend, so.
Yeah, no, this is fine. Do you want to start working on the other side? I think I
Sure.
can do this. And then I feel like this is something that's going to end up kind of montaged / kind of fast forwarded. It occurs to me that your devious plan of using both of them leaves us with no backup plan if one of them fails. Do you have another one of these kits on hand?
Nope, we just cannot screw this up.
Oh joy.
What are you doing?
Just hold on, okay?
Like, why is it crisscrossed?
It's applesauce, okay?
Yeah, this is very much not applesauce.
I'm
This
an
is copper
enthusiast.
that's
I'm an
work hardening
enthusiast.
that we only have one of.
I'm an applesauce enthusiast.
You put applesauce in oats and leave them overnight. It tastes really good in the morning.
Alex food tubes. I think I've got it. It's a duck. No, it's a dinosaur.
It is a dinosaur. What is mine?
Wait. Your plan is to solder this to the heat pipes out of the laptop
Yeah,
and then just hope to God the whole thing fits back in?
it's gonna be easy. We just need to solder them to this. We know where these need to be because it just lines up with this little heatsink. It's gonna be fine. Problem is, we need to remove the paint off this to solder.
Oh, for crying out loud, Alex. I'm super stressed. This is not as easy as you made it out to be. An hour, he said.
Yeah, an hour if you're using thermal epoxy.
Why are we soldering again?
Because you said that you really wanted to solder.
That's what the people came here to see. Us soldering to heat pipes and them hopefully not blowing up. Things are about to get a little messy now because ASUS uses liquid metal on the CPU. Oh crap, on both of them? Really?
Guess so.
Oh wow. Okay. Interesting. It's like a cover that looks sort of like Captain tape that keeps the liquid metal, when it inevitably does leak, from shorting anything on the package for these chips. Then they've got these little barriers that keep the liquid metal from getting out of their little cavities. That looks an awful lot like K5 Pro.
It really does.
I still hate it.
It's great stuff. Fantastic stuff.
How did you want to strip the paint off this?
Bench grinder.
Oh no.
Do you want me to do it?
Yeah.
What about
Yeah,
you
I
do
do.
it?
What? Why would you even offer if you're just gonna...
I thought you were gonna say no.
Sorry, I'm using this?
Yeah, do it somewhere that it doesn't really matter, like over here. That'll be nice and easy. And you can just see, you'll just be like, more, and then there'll be no paint.
Okay. All right. It's not that bad.
Okay, can I see it? I wanna like get home on time this evening.
But what about the foam and stuff?
It's leaving.
Well, wait, we can't have the foam leave. It's got the airflow paths.
Yeah, but we have more foam. I bought more foam.
Oh, God. Well, he doesn't tell me these things. I'm sitting here being careful not to damage the foam, and he's like, oh, you're taking too long.
There you go.
Wow, that looks awesome.
Yeah.
Fantastic. Oh, dang it. Wow, we didn't even shmoo up the bottom that badly.
Yeah, and like if we did, it's just copper. It'll make it more conductive.
No, that's not how that works.
What? Sure, why not? Also electrically conductive, which isn't fantastic, but
We did a sanity check because we're careful like that. Made our marks, and now it is time to get fancy. Meet Nate from Creator Warehouse. I
Hello.
don't think he's been on video before, but he's going to show us how to solder to heat pipes.
This is not how you solder to a heat pipe, but it's a way to do it.
Thanks, Nate.
Yeah, you're welcome.
Step 1, clamp the heat pipe.
With non-meltable clamps, that's important, but not too hard. We don't want to.
Whoa, hold on. You gotta check the other side of what business is going on.
No,
I got some tech tips too.
liquid metal, huh?
That looks pretty good. Before we go any farther, what am I looking at here?
This is a rework station commonly used in reworking electronics. It allows
Sure.
you to heat up the board to an ideal temperature for soldering.
So just shy of
Just shy
The
of,
melting point.
of the melting point of the
Got
solder.
it.
So you can very precisely remove components quickly.
You said this is glass, so is it like infrared heat? Or?
Yep, infrared heat. We have a bunch of coils under there.
Ooh, very cool. Or hot. I'm proud of that.
I'm proud of you, Linus.
And we will, of course, monitor the bottom of this, even though this is far overkill for the circuitry we're working on, or the lack of circuitry.
This really is making that thermal epoxy option sound pretty good, Alex.
It sounded good the whole time.
Whose idea was this?
This is me.
It was you?
Yeah, well, Alex always told me it's really hard to solder to heat pipes, and every time I've been like, oh, but we should figure out how to do it at some point, because that would be cool.
We have done it.
When did we do it?
We did it before.
Well, we didn't do it in the play button PC,
No,
I know
we
that
did.
much.
Remember?
No, we didn't. No,
we did.
We've argued about this before. We didn't. I disassembled it after to fix the thermal issues. It was epoxied. Actually, no, it was just thermal paste. We didn't even put epoxy in it.
No, there was a combo.
While these two figure that out, I'm going to start the element heating up.
How are we doing here?
80 degrees.
Oh, wow, that's heating up real fast. So I should touch it then, right?
Radiative heat transfer is cool. I mean hot, but
Yeah!
he's rubbing off on me.
I'm getting bored.
That's not a board, that's a heat gun.
As you probably can guess, this cooler is pretty good at cooling, so I'm gonna just throw some rags on it and hope that the rag doesn't light on fire.
This is board.
You
100 degrees Celsius, I should touch it with my finger now.
Yeah.
I'm only half kidding.
This is taking a very long time.
Here, you hold this.
Oh wait, it's 100 degrees. I can do that.
I told Linus to do something, it was great.
What temperature are we aiming for here?
In the 130, 140 range.
Oh, okay.
With this, once we do that, I'll apply the thermal paste and we'll see how it flows.
By thermal paste, he means paste form solder.
Yeah, thermal paste.
Not thermal paste.
Oh, sorry. You're right.
If you're wondering, Tessa tape starts melting at around 200 degrees Celsius.
Okay, I mean, we're at 130. That's what you said we were doing, right?
Let's try it. I'm going to squeeze that in. Right.
Okay, maybe just a little to start?
I mean, we want it to flow.
Yeah. I mean, if she's flowing.
There you go. Oh, it's doing it!
It's doing the thing. We're going to use the whole...
Heck yeah.
whole
Whoa! What just happened? She did a thing.
I don't know.
Crap. I think she detached from the bottom one.
That's fine.
That's not fine.
Oh wait, it detached from like...
Yeah, it did.
Oh.
I think they used the same solder we used.
That's not good.
So I say we heat it up and we take the clamp and we clamp it back
Clamp
together.
the whole thing, yeah.
Maybe with a little bit of this in between.
Yeah, it makes a ton of sense they would be using the same solder we are.
I don't know. I thought that it made a lot more sense that they would be using higher temperature stuff.
Needle nose vice grips.
I know. I can get precise with this.
And what, I just melted again?
Yeah.
I'm a little worried about giving her too much beans here because then we might start detaching other things from other things.
So maybe we just continue
Yeah, I think we just...
and do some of that. There we go. I saw it attached to the bottom.
Can we get like a bunch right in here? Because that's, I think, like a really key.
Okay, hold on. Let me...
No, you're good.
No, that's already lots. It's on.
Or I mean like right in here.
Yeah.
Guys, I really don't think we need that much. Once it's soldered, it's soldered. It's not...
Thermal contact area, Linus. Thermal contact area.
I'm just really worried this thing is going to come apart again.
Probably will.
Well,
Yep.
Yep.
geez, guys. Why did we... Okay. Are we calling that good?
Yeah, let's cool it down.
Oh, lordy.
Looks good. Great even.
Great's a super strong word to describe this, but I think we might have done it. Question for you. This is all fine and good, but do we have fittings for the ends of these?
Yeah.
Oh, can I see them? They're so cute. Look at the little nice one. Oh, are these compressions too?
Yep.
No way! Wow, so secure, won't even leak. Fresh strategy this time. Instead of using the heat gun to melt the solder, we are going to use a soldering iron.
This is more how this tool is meant to be used.
I'm putting on less.
I'm putting on less. Murders the whole thing.
Well, no, that's how he did it. Ooh, well, this
Wow.
works great.
Yeah, that was so much better.
I breathed that I'm right in. Wow. Yep. Hell of a drug.
Someone's gonna have hallucinations this evening.
Oh yeah, that's way better. Yeah, I'd let it cool off a little bit.
No.
Well, you're gonna risk delaminating because this temp over here is up to 130.
Mm-hmm. No, I got this. Damn it! It totally did it, didn't it?
Yeah.
Ah, crap. Wait, I can't be adding that much heat with this thing, can I?
It's at 380 degrees Celsius.
Okay, what
Something
just
just
happened?
really moved. Yeah, it's not happy at all. We need more clamps. This heat pipe fell off.
Okay.
Ah. So can we take this?
We need the long boy.
We do need the long, or I could just use this.
Oh, God.
I don't know about that.
Oh, God, that just moved. Oh, crap.
Oh, that's gone. Yeah.
Okay, this might actually be bad now. What about this one? We
Oh,
can't-
this one isn't.
Oh, God. I think that's the GG, boys. Okay. This is detached.
Yeah, I think GPU and CPU are fine.
Yeah, actually, they do look fine.
This one's not looking too good.
Well, no, yeah, thanks for that. Everything else here looks not bad.
Yeah, it's salvageable.
I think turning a perfectly good laptop into salvageable is nothing to be proud of, but
If only there was another way we could have done this.
why did I say I wanted to use the solder?
1 to 2 more degrees of cooling.
No. So there would be learning outcomes for the video.
Okay, yeah.
Did we learn?
Yeah. F. All right, day 2, here's the plan. We have our environmental chamber and we have gotten rid of the safety limits and it is now at 180 degrees Celsius. We have our heat sink here, which has been clamped a whole bunch. I did a little Home Depot run and bought 10 of them today. And we should be able to just huck it in there and hopefully it's all fine. I guess that one needs to be a bit tighter. Now, ideally for this solder that we have here, you would have a curve that looks something like this to melt it. Unfortunately, we can't do that. This thing's way too big to do that rapid of heating, so we're just gonna chuck it in there and hope for the best.
In you go.
There. Oh, I bent that heat pipe so bad.
Okay, that's a Bernie boy.
Yeah, that's really hot, I imagine. We have our thermal probe attached, so we know how hot it is, and once it gets to around 160 degrees, we should be about good.
We have solder drops on the bottom of the thing.
Ah, nice.
All right, so we're liquid then.
We're nearly at 165 degrees. When we hit that, we're gonna
Oh.
kill the chamber. Yep. Turn on the fan. And with any luck, we can cool it down half fast.
Probably don't breathe
Wow,
those
that's a
fumes
lot
in.
of heat. It's dropping fast, dropping fast. Okay, yep. Whole thing hasn't exploded yet, so that's nice. My first impressions just looking at it are not good. Oh, you wanna do it?
Yeah, why not?
Sure.
That way it can be my fault if it all goes wrong.
Yep.
What level of monstrosity have you unleashed on the world? It's got more clamps than a Tetsuya Nomura character's buckles.
The VRM heat pipe looks like it's come off, but the rest might be fine. Let's have a look without clamps.
Yeah, it looks like it might just be that one VRM heatsink.
Yeah. I'm a little bit concerned about how flat some of these heat pipes are, but overall that was pretty darn good. The VRM heat pipe right here has come off a bit, but that's not super important. So I think that we can just maybe reattach that with some thermal adhesive. Well, maybe it worked. I guess we put it back in the laptop now.
This is not going to work because these are bare dies
Yep.
and these need to be perfectly flat in order to cool them.
I'm not the most hopeful I've ever been. My thought is we just goop thermal paste in there.
K5 Pro.
K5 Pro works too.
Oh, he already had it ready. For the uninitiated, K5 Pro is essentially a liquid thermal pad.
Oh, I didn't mean in there.
Oh, you said VRMs.
Yeah. Do you see the bit where the VRM pad is detached from the heat pipe?
Oh, like in there.
Yeah, in there.
Oh, that'll be fine. It'll act as a heat spreader anyway. It's attached on this side. I'm not worried about that. Feels like cake decorating, except grosser. Is this Intel's laptop?
I think it's ASUS's laptop that they gave us because Intel asked them to.
Oh, sorry, ASUS. You guys have definitely screwed some stuff up over the last little bit, but you didn't do anything to deserve this. You ready? Moment of truth.
Oh, it seems like it really wants to go in there.
Nope, that's not how I would describe it. You know what? I think we're well clear. And then are we just gonna do the rotary tool just making it happen method?
I think so.
Well, that's some pretty robust plastic they got themselves there.
You saw how it flies out last time, right?
Can't hear of the sound of my excellent, totally approved hearing protection. I think it goes, Alex.
Oh yeah, not bad.
Okay.
Cool.
Yeah. All right. I think it's time to screw this down and see if it actually goes.
Yeah.
Oh, this is messed up, dude. Shoot, did I just cross-thread that too, adding insult to injury?
Are you sure that's the right screw?
Nope. What are the odds this powers on at all?
Oh, I think it's gonna power on.
I don't know, with all the strain we're putting on the board. I've seen it not work.
Yeah, true, I have to. That's normally when there's like an actual socket.
Okay, I think that screw is free spinning now. So that's good.
Oh, that just popped out of the board.
Yep. Popped right out of the standoff.
That's a really bad sign.
That's really, really bad. There is no obvious way to put that back in at this time. I told you about the chassis intrusion thing, so we can't even just boot this up without it all closed up.
Yeah.
Yeah. Now for this, I'm thinking we put a piece of rubber between the bottom of the chassis and this spot right here just to push down on it.
I don't have any better ideas. Where does this have to, Linus.
Balls. Oh, balls, 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 balls.
Do you know why that GPU was so hard to put in?
Oh, balls, 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 balls.
The fan connector's in there. Ah, yes.
Oh crap, it just pulled out that standoff. Okay.
I really wish we had spares.
We do have a spare.
We have a spare laptop, we don't have spare copper tubes.
Oh no. So we would have to salvage them off of here.
Yes.
Let's do whatever it takes to not go down that path. This is literally disastrous.
Yeah, my hopes are not high. Not high at all.
I'm getting this thing closed.
I was looking maybe a little bit of this stuff right here to try and push that GPU down.
Yeah, that seems pretty good to me. That is really thick.
Yeah, I don't know if it'll work, but
We might want to go with slightly smaller pieces, more like right on the pressure points. Because putting it all across this is just going to put a ton of the pressure here.
yeah, but we kind of need the pressure like right here the most part, don't we?
I mean, yeah.
I say we just see what happens like that, and if it feels like it's not going to work, we can remove some.
Okay. I have 2 screws though left over.
We're very confident that this laptop's going to work.
Did that catch?
Yep.
It's not even that bulged. It's here, it's raw.
Did you plug in the
Moment
battery?
of truth. Well, that's a plus.
Yeah, super easy to take apart now. Bottom cover just pops right off.
There it is. Okay, moment of truth attempt number the 2nd.
I've never wanted to hear that stupid swing so much in my life.
I don't think she's swinging.
It's really not looking good, is it?
No, I think it's dead. One thing, it didn't shut down immediately, which does make...
Oh my God!
What? No! No way! After all that time, are you kidding me? I was sitting here thinking, why don't we try an external display? Maybe we messed up the ribbon cable.
Look at this keyboard.
Shh, don't talk about the keyboard like that, okay? It's Thanksgiving. You had some dinner full of turkey. Well, there were turkeys involved. Let's have a looky-boo here, shall we? Here's where we're at. CPU, 70 degrees. GPU, 0.
0. Well, that's an improvement.
I don't make the rules.
Does it actually exist?
Device manager, display adapters. I mean, it's in there.
Do we try and run a game?
Valheim. I want to see if this GPU comes to life. Oh, hey, it did.
Oh,
whoa, 50 degrees. Okay, those fans are going. They're going. But you know what's kind of wild? CPU package power is up to 40 watts. We're at 86 degrees. It actually seems to have it under control. GPU temps are 75. Holy sh**, I think it still works. Holy crap, 170 FPS.
It's actually not bad.
The 1% lows, they dip. I think that may be something to do with the cooling being kind of messed up. But our GPU is at 78 and our CPU is at almost 4 gigahertz, 74 degrees.
That's actually really impressive. Should we grab the other one to see how we're actually doing?
Fine. Did we have a plan to seal these threads or O-rings or something?
I was kind of thinking that we would just throw like the smallest amount of Teflon tape on there or something like that.
This isn't as far off as I was expecting.
Really? Wait, what?
So our GPU is at about 1600 megahertz on this one, and it's at about 1600. It's actually.
Did it survive? Alex, tell me it survived!
It's doing a lot better than I ever would have expected.
It survived.
It's really looking like it survived.
Yeah! Woo! Oh, that's so exciting!
We should try something a little bit more comparable.
I don't know why the GPU telemetry is broken on that one. Oh, whoa, 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 check this out, check this out. No, Glenn, check this out, check this out. This CPU's turboing to 5.15, almost 5.2. It's because this one has extra heat pipes. Let's go! Okay, that's only at 3.8 now. It seems to be a little all over the place because this one's at 4. This one's at 4.4. Interesting. 155 average versus 170, but kind of expected that. GPU telemetry is not working for some reason, but it's clearly running faster. But we can fix that. Wait, this is our water cooling reservoir?
Yeah.
Really? That's what you got? Those are the cutest Y fittings
Yeah.
I've ever seen. For real though, guys, if it hadn't been for the disastrous outcome from heating up the heat pipe assembly, this wouldn't be that bad. I mean, it doesn't look factory by any stretch of the imagination, but I don't know, it's pretty clean, huh? What? What?
That's not too bad.
Yeah! I know this isn't the world's most perfect benchmark, but we've got frame view running right now. We are rendering the menu in this game. If we pump water through it and FPS go up or temps go down, we did good.
Yeah.
Okay, this is it. Moment of truth, guys. Watch this
Pumps
water,
on.
watch the water. Oh, whoa, whoa, she's full. Wow, she's chilling. Okay, okay. How's our FPS doing? How's our, wait, I forget,
Oh,
is this
something's
CPU or
leaking.
GPU? It's leaking, what do you mean leaking?
You pulled the tube out.
No, I don't know what you're talking about. Is this the CPU side? Because our CPU is at 70 degrees now.
Oh, wow. It was at 80 before. Is it actually working?
Oh, our FPS. It was a CPU cooling issue. We're up to the exact same FPS. Let's go. Yeah! Woo! Water cooling to the rescue. I mean, it only solved the problem that we ourselves created, but we are 10 degrees cooler than the air-cooled laptop even after we mangled it. That is flippin' crazy. It's not even leaking.
I honestly cannot believe it. Things were looking desperate a couple minutes ago.
Wow, we are 15 degrees clear of this one as they're both heating up here. Almost 20. We're not going to be able to compare our GPU temps because this one's being a butthead, but what we will be able to measure is FPS. And I think we're going to beat the air-cooled laptop. Okay, what's the best way to do this? Should we just turn off the pump temporarily?
Yeah, I just did.
Plumb this up to the other side, and then we'll just go in serial.
Oh, I don't want to do serial. 'Cause
No?
This looks really restrictive.
The Y adapter.
Yes, the Y adapters.
Nice. Feel this. Tell me which side is the cold side and which side is the warm side.
This is the warm side.
Oh yeah.
It's very noticeable.
You're right then. There's no way that we can go serial. We don't want to be feeding that hot water to
Yeah,
our
no.
GPU. Under normal circumstances in a water cooling loop, the order of the components doesn't matter at all. But this is such a tiny, tiny volume of water, and the amount of heat that we're pumping into it is so much that it does make a difference. It's kind of like being peed on. What? I was a bedwetter till I was like 15. I know. It's not weird. Just give her the old snip. There's not that much water in these tubes, so
Yeah.
it doesn't really matter if it leaks a little. I'm having a lot more fun now than I was half an hour ago. I'm sure you're on the same
Yeah.
page there too. Oh my goodness. What a roller coaster this has been. Now I suspect the supplier of this kit intends for you to use just one of those tubes.
Probably.
And then the other one is just because you'll probably screw up the first one. But I think our solution with the Y splitters, cooling the CPU and GPU on independent loops, is going to perform better. You can see in our screen recordings that our FPS in the menu here has dropped on the water-cooled machine, and that's just because we screwed up the cooler earlier. But Alex, if you turn on the water cooler, I think we are about to see some spectacular results. Our GPU's at around 1600 megahertz right now. It's on. She's getting water now. GPU's down 10 degrees already. 68, 2,000 megahertz. Oh, this is very interesting. We just dropped over 10 degrees on our GPU. God. We just boosted another 2.3. It popped up to 2.3 for a second there. Drag race time. Bear in mind, we have screen cap running this time. We didn't last time, so this is not meant to be comparable to our first results. This is meant to be comparable to each other. Neck and neck, but what's not neck and neck is the temps. We don't have GPU temps on this one, unfortunately, but our CPU's at 82 degrees. We are beating that by over 10 degrees on our water-cooled laptop.
That CPU's at 5.4 gigahertz.
Oh yeah. Oh yeah.
I'm honestly really impressed with ASUS and how much power they just will give you when you have the cooling.
I'm so excited to have the same performance as the air-cooled one. You know what, though? Is it at least quieter? No, not really. Is it cooler? Yes! Alex! Dude!
This one is too.
Oh, wow, it is. Wow, good job, ASUS.
Yeah, they have a thing that like takes a bit of the fan and blows it through the keyboard to keep it cool.
Oh.
What's that? 24 degrees on supply. 30, 31, 32 on return.
Wow.
That's crazy.
It's got to be the same on the other side. This is the GPU side. I bet this one's even going to be more.
This one's considerably cooler on the inlet.
I told you, with that exhaust here, I think it's actually heating it up significantly. Okay, results time. We won!
Haha!
Yeah! Let's go!
I honestly can't believe it. And now we overclock so we can win more.
Yeah!
I spent the last couple hours overclocking these, and out of the gate they frickin' rip. With just the Windows default power plan and on the air-cooled laptop, I was able to immediately get 27,327 points in Cinebench R23. For comparison, that is higher than the score we got with the i9 12900K when we first reviewed it. And we haven't even tried to make it faster yet. Next easiest thing to do is go into ASUS's Armory crate right here, and just simply whack the power limits to the max, getting us a tasty 175 watts on the CPU and netting us an incredible 30,307 points in Cinebench. Damn. Although it was clear by the end of the run that ASUS's thermal solution was becoming the bottleneck, not the CPU itself. And like, we did just spend a whole video water cooling laptop, so let's send it. And it is so good. We were able to just lock it at 175 watts and managed a 31,418 on our first run with it. Not bad at all, although after that things started getting difficult. Even though the thermals were in check, the current limits on the VRMs were just immediately getting hit, which is where the true hero of laptop overclocking comes in, undervolting. On a desktop in XTU, you can play with all of the stuff in here. On a laptop, core voltage offset, just make it lower and it will go faster. Basically what we're doing is the CPU will consume less power for the same clock speed, making it more power efficient, allowing us to get more out of those 175 watts that are available to us. The fastest run I managed was a blistering 32,406 in Cinebench with a minus 0.125 volt offset. Curiously, I slapped a minus 0.135 volt offset on the air-cooled laptop and broke 32,000 points as well, meaning that you can just render videos super fast with this thing, even without the water cooling, although I did prop it up with the power brick. The best part about undervolting your CPU is that it will also make your laptop faster in games. The largest obstacle in games is just the total power of the laptop, in this case 230 watts, and by allowing the CPU to run more efficiently, the GPU can then gobble up more power and yeet more frames at your face.
Our hotspot at the top of the keyboard here is 46, 47? Let's say 48, 48. On this one, 53?
Oh, wow.
Yeah!
That's meaningful.
No, it is. Just like this meaningful segue to Wait, no, Intel sponsored this video. If you guys liked the vibe of this video, I have plenty of other options for places to send you, but I think the best one is probably that AliExpress cooler we bought to replace the cooler in Alienware that was like a pre-done version of this, except it made it barely even work on air cooling. That thing was a disaster.
We somehow did better.